Mathematics 2, May 2016 exam, question 2. You are a business analyst for a major bank. Two entrepreneurs have asked you to fund their business proposal. The proposal is to develop a web application that automatically collects geographical location data and feeds that into a range of analysis applications. Once the application is launched, the entrepreneurs expect to have 1 user in the first month, 2 users in the second month, 4 in the third month, and so on. If each user pays £1 a month, find out how much income the entrepreneurs will receive in the 6th month. Well, let's draw a table just to see what that looks like. One user in the first month after launch, 2 in the second month, 4 in the third month, 8 in the fourth month, and so on. So this is obviously a geometric progression. The first term is 1 and the common ratio is 2. So the 6th term is a times r to the n minus 1, where a is the first term and n is the number of months and r is the common ratio. So that's equal to 1 times 2 to the 6 minus 1, which is 2 to the 5. 2 to the 5 is 32. In the 6th month, the entrepreneurs will receive £32. Part 2. What is the total income for the first year after the launch? So that's the sum to 12 terms. Let's just remind ourselves of the formula. It's the sum to 12 terms of a GP, which is this equation here. So for the first year, it's a times r to the n minus 1 over r minus 1. N is going to be 12, r is 2, and a is 1. So that basically boils down to 2 to the 12 minus 1. 2 to the 12 is 4096, so 2 to the 12 minus 1 is 4095. Part 3. How long will it take for them to generate £25,000? Well, we use the same equation in effect, but this time what we're saying is that the sum to n terms is going to be greater than or equal to £25,000. Now, this is already 4,000, so if you think about it, double that is 8, double that is 16, double that is 32. So we know roughly where the answer is going to be. It's going to be around 15, isn't it? Anyway, putting the values into this equation, we get 2 to the n. It's actually 2 to the n minus 1 is greater than or equal to 25,000. So I'm ignoring the 1 for simplicity. So 2 to the n has got to be greater than or equal to 25,000. So taking the logs of both sides, I've got n is equal to log to the base 2 of 25,000. Log to the base 2 of 25,000 is 14.61. So it's going to take 15 months to generate £25,000. Part 4. Giving your reasons, state whether you would approve or reject the loan. You can either accept or reject it as long as you have a good reason. If they seemed credible, I'd be inclined to accept this because this is going to grow a bit like Google or Facebook or something like that. If they're doubling every month, it's not going to take many months before it's a huge amount. On the other hand, if I didn't trust them or I didn't feel they really understood what they were doing, then I would reject it. So it's up to you to either accept it or reject it, but give a reason that justifies it. Part B. The sum to 15 of 3m plus 1. So let's generate the first few terms. They go 4, 7, 11. So this is clearly an arithmetic series. The first term is 4 and the common difference is 3. So if we go to the equation for arithmetic progression, arithmetic series, that's how we find the if we go to the equation for sum to n terms is there, which means the sum to 15 terms is 2 times 4 plus 15 minus 1 times 3, which evaluates to 375. Part 2. Again, we'll calculate the first terms. 2 to the 0 is 1, 2 to the 1 is a half, and so on. So the series is going to go 1, half, quarter, eighth, and so on. So it's clearly a geometric series. The first term is 1 and the common ratio is a half. So the sum to n terms, we'll just look at the formulae. Sum to n terms is given by this expression. So it's 1 minus a half to the power of 9 over a half. And that gives us 1.996.